Okay, thank you for joining a bit earlier tonight, guys. I know obviously it's not usual, but just given that we want to do a 2-hour session, it's better to start a bit earlier than to go too late with it. Yeah, so welcome. We're basically going to be finishing up the little bit of stats. I'm going to go through the 2 types of t-tests that you need to know about, and obviously how to calculate them. And then we will spend some time speaking about the exam, which obviously is everyone's main focus currently, which is completely and utterly understandable. So yeah, I'm going to try and just go through. What I'll do is actually go through the brief from last year that was released, because maybe I know they didn't give out a new brief this year. So I will go over that one because it will be useful to you guys. And then I thought we'd go over a past paper actually together. So we can have a look at the types of questions that generally come up, and you can see the sort of patterns and the types of questions that you need to answer. And it's actually not that bad. I don't know if anyone's had a chance to have a look at the past papers. Yeah, but I think they could be worse, to be honest. Like last year, my class actually said that they were quite pleasantly surprised that the paper was fine. So I was happy to hear that, and I do hope obviously that you guys have the same experience as well. All right, yeah, so I think are you guys ready for t-tests? I think just before we start, I think just remind us what we've been doing up until this point. So obviously we've done descriptive statistics. We then did some correlation, and then spoke about hypothesis testing and making hypotheses last week. Well, it was last week, right? Yeah, last session. And then now the last bit of calculation that you may need to do is a t-test. Okay, so that is where we have arrived at the moment. Hopefully everyone does remember at least the steps of hypothesis testing, because yeah, we're going to go over that again now. And just, it's just the way that we would approach doing this kind of testing. The whole purpose is to test an hypothesis at the end of the day. Ready? Okay, so if we remember from a couple of sessions ago, the purpose of a correlation is to test for a relationship and then to be able to describe that kind of relationship. So whether there's, a positive correlation or a negative one or a strong one or a weak one and that kind of thing, it's about a relationship. But t-tests do something different. The purpose of a t-test is to compare the means of 2 groups together and to determine if there is significant statistical difference between them. So essentially, this would be when you have 2 groups of participants or respondents rather in a research study. The go-to example is easy to understand, is if you're doing something with like males versus females for whatever reason, that would be 2 independent groups of people, okay, that you have. There are 2 separate groups of data, and you want to know if there is a significant difference between them, based on whatever variable you are assessing. And there are various ways to do this depending on the types of groups. But yeah, the main thing to remember is that whenever you are asked to compare a group mean, you are looking at a t-test. Whether you are comparing the mean of one group that you've measured to a general population figure that you've got, which will be the first one that we do, or whether you have 2 actual groups that you've measured that you want to compare together. Okay. Okay, and again, because this is an inferential test, you do operate on the assumption that your data is normally distributed, and obviously have equal or unequal variances, and it really depends on the type of test, but that's not really significant at this point, just that your data has to be normally distributed to be able to do a test like this. Okay. So, types of t-tests. There are these 2 types of t-tests that you will be doing in this module. Okay, so we've got a single sample, or in other words, a dependent t-test. This is also sometimes referred to as a student's t-test. If you are, looking online for practice and things, that is what this means. And essentially, that is when you only have one group and you want to see if there's a significant difference between your group's mean and the general, maybe the general population mean that you know. So you'd have to know the general population mean, okay, in order to compare anything. But yeah, to test against some other hypothetical mean that you have, depending on the situation. And then you have an independent samples t-test. So this is when we have two means, two groups, and there's nothing that relates the groups together. They are two separate groups, so they would have had to have been individual people, different groups. And that is when you want to compare the mean of something. So for instance, this is very common when you're doing a true experimental design, when you've got a pre-test, post-test, and then you've got an experiment group and a placebo group, or a control group, in other words. Those would be two groups. So you've got, like, if you're doing a clinical trial for some kind of medication, your experimental group would be the group that gets the drug, and then your placebo or your control group would be the group that doesn't, right? And so then you have two groups to measure against each other. Okay, are we all together with that, with the different types of tests? So essentially you're doing the same thing. They just have different formulae, because obviously one is testing one group against a hypothetical mean or a population, and then the other is testing two groups that you have together. Okay. All right, let's go to this one sample t-test, or the dependence, or also known as the student sample t-test, one sample t-test. Okay. So essentially, and this kind of applies to a lot of the examples that I speak about a lot, if I want to know if whatever group that I've measured compares or is different to another hypothetical population mean. And really, so I'll put it into context, and this is the example we're going to use, is like, let's say I am analyzing your guys' assignment results as a class, your average results, and I want to know if you guys have performed significantly differently to the overall average of the rest of the campuses at Varsity College, right? So then I would have obviously all of your individual data and all of that, and then I'd be able to work out the mean and all kinds of things. And then I would have to obviously get a value from Varsity College of the overall mean of all of the rest of the other campuses to see how you guys would compare. So that is pretty much a likely scenario that you may encounter in the exam, something like that. But at the end of the day, it's just, you ask yourself, okay, do I have one group or do I have two groups? And then really that will make the decision for you as to which test you're looking at this stage. Okay, so you have to be given this normative population mean, or this hypothetical mean, in order to do this calculation. Okay, so you will always be given that. If they give you a scenario, it would read something like, you want to know if your class's results are significantly different to Joburg's campus average or whatever. And then they'll say, like, they may not say, population mean with this little mu symbol thing equals whatever, but they'll say something like the population mean, or this other mean that you're comparing it to is, and then give you a value. So they will always have to provide you with that value at the very least. Yeah, they may be really kind and actually just give you the values you need, and you may just have to sub it into a formula. And yes, you will be given the formula that you need, if you need them at all, really. Hopefully you won't, but I mean, I don't know. I haven't seen the paper. Okay, so just judging by the papers I've seen in the past as well, just as an aside, they generally put the formula in the question where you need it, which is useful. It means you don't have to be paging to the back or anything to find the formulae. It's very likely that if you need a formula, they will pop it there for you so that you can see it when they ask the question. Okay, so this is what this formula looks like. It's actually so not that bad. It's actually far less intimidating to me as a formula than like the one for correlation, for example. I mean, there's just so many less things going on in there. Yeah, so I'm going to break down now what these symbols mean and show you how to calculate it. Okay. Good evening to those of you who just joined. Basically just getting into, yeah, this type of t-test, one sample t-test. Okay, so yeah, this is also kind of the nice part about how they tend to set the exam papers up. I mean, if they give you the formula in the question that they're requiring it, you don't even necessarily need to remember which ones are for which. I don't recommend ignoring that. Like, I do recommend being able to identify the formula that goes each test that you need to know. Just it will help with things like anxiety. Okay, so just one sample t-test. This is what the formula looks like, and you will see the two sample t-test does look quite different to this. So you will be able to distinguish between them. And obviously the R, if it's a correlation formula, this is an R. Okay, so that's really the signal that would show you which formula are for what. Okay, let's break this one down. Okay, so this is what the formula looks like for a one sample or a student's t-test. Okay, so this X, as usual, when you see an X with a bar on top, that means the mean of your sample. So with this, example that we've been chatting about, that would be your class's average score. I went and I added up all 143 of you scores for something, and then divided by 143 and got the answer. That would be the mean. Okay, and then really what is new to you guys at this stage is this symbol. It is called mu, and really this represents the comparison mean. So the mean that you are comparing your group to. That can be and will likely be in the form of a population. Okay, it's called mu, like Mew, like the Pokemon. It's a lowercase Greek letter. It's not that, I mean, it's just to know what this means, essentially. Yeah, I call it the funny U thing. I mean, a lot of the time, people just come up with weird names for these things. It's not that essential. I think you spell it M-E-W. I'm not super sure, actually, because, I mean, it's a Greek letter, so spelling Greek letters is, like, weird to me. But anyway, that's what this symbol means. Okay, when you see this, it means population. And in the context of this formula, it means that thing you're comparing it to, okay, that population you're comparing it to. All right, and then at the bottom, what is useful is to remember that the S means the same thing that it's been meaning throughout the module. It means standard deviation. Okay, so that means if you are required to calculate a t-test, you will have to calculate the standard deviation. They may also give that to you, obviously bearing in mind, the time that you'd be given to write this paper. But we'll chat about that now when we get to the paper. And then N, as usual, is the sample size. Okay. And I'll show you now, I've got another slide talking about this whole denominator. You can actually take a step to work this out on its own, but essentially not that necessary. The main thing is to work out the standard deviation and the mean of your sample, and then you will be given your population mean to compare to, and yeah, you will have to be given N. So if they don't give you the full data set and they're just giving you numbers, they'll have to give you N as well, and then you just sub it in and work it out. Yes, I will post these slides. So actually what's ended up happening is this is all one slideshow right from the beginning of correlation, and I've just kind of built it up. So after tonight, because I'm going to draw on the slide with the the answers that we come up with, then I will upload the PDF for you guys. Okay, so I've basically broken down how to work these formulae out into steps. And essentially just to help you so that you don't freak out. And essentially step one is don't panic when you are confronted with something like this. Okay, so this is just remember that formula for the mean from descriptive statistics, but you work out the mean by adding up all of your values and then dividing by N, dividing by the number of your sample. Okay, so that would be step one. You need to know what this symbol is, you need to know what the mean is in order to sub it into your formula. So you'd go ahead and you'd calculate that if it's not given to you already. Okay. Okay, step two. Now this is kind of the longest part of working out a t-test, is working out the standard deviation. And honestly, in none of the past papers that I've seen have they asked you to do this because it takes time. But we will be doing it for practice just in cases. And this is really an important part of how to solve the rest of the formula is you need to work out the standard deviation of your sample. Okay, so we did do this. I think it was even in that first session on stats. And we'll go through it again in an example now. If it's triggering any memories for you guys, it's using that table and you work out what x is and then what x minus the mean is, etc. Okay. And then you can actually, I put this in here because it's nice to be able to just work this out on its own. So from step 2, you work out the standard deviation, which is also just S. You're going to just ignore this D here. It's just sometimes it is presented as SD for standard deviation. And then, so you'd plug in whatever answer you get from here into the top here, and then you'd put it over the square root of your n. Okay, so whatever the n is in your given situation. And then you go ahead and plop those values into the overall formula and work it out. Okay, so yeah, they've said that you will be given the formulae that you need, and that includes the formula for standard deviation. So yeah, I mean, the ones that you probably won't be given will be little ones like this, like for the mean, right? So just know how to work out the mean without needing the formula for it. Okay, it's going to be fine. Let's go and have a look at the next step, which is the last thing. Okay, so essentially what the whole point of doing any of these tests is to make a decision, right? You've come up with hypotheses, you've put them to the test, and now you need to be able to make a decision. And so what helps you to do that is by assigning a critical, figuring out what the critical value for your test is. Okay, and yeah, so in your past papers, you have not been asked to run a full hypothesis test. Following all of the steps and then coming to the conclusion. That's actually something you do more at an honors level through that whole process. It's possible that you'd just be asked to explain, what is the purpose of hypothesis testing? Why do you do it? But yeah, I'm obviously going to just show you how this is done so that it makes sense. Okay. So when you do a t-test, you then would have your value, whatever t-value you get, and you would then be comparing that to a critical value. Okay, so to get the critical value, and you can essentially find this before you even do your calculation, but it doesn't matter when you do it. You need to know what your degrees of freedom are. That's what this DF means, and it is simply for this test, for a one sample t-test, it's n minus 1. So let's say there are 143 of you. That means my degrees of freedom would be 142. Okay. Yeah, just depending on whatever that is. And also, yes, you would be given a table if you are required to use one. But I really genuinely doubt it because it hasn't come up in any past papers, and it's something that takes time. Okay. But yeah, how we find this value is really looking at just these confusing different columns. So this is why you need to know if your hypothesis was one or two-tailed from the beginning, and just try and cast your minds back to last week where we discussed one and two-tailed hypotheses, and that's really just so that you know which row that you're following at the top here, and then you would be selecting, depending on whether it's a one or two-tailed test, you'd be looking in the column for 0.05. Okay, so yeah, these kind of little technicalities, these are things that you'd have to be confronted with at an honors level. I'm really doing this now just to show you how we get to this end product in a t-test. Okay, so if you have a one-tailed test and you have a significance level of 0.05, which is kind of the industry standard, you would be looking at this column. You would then be finding your degrees of freedom. Okay, so obviously this isn't specific, and yeah, the larger your sample size gets, the more kind of generalized it is. and you pick the one that's closest in your table. So I had 142, so I'm going to go along this row of 100 here. So my critical value would be 1.660. Okay, and essentially what we do with this critical value is this determines whether you accept or you reject your null hypothesis. Okay, 0.05, because that signifies a 95% confidence level, which means that you're basically allowing in your calculations for a 5% error. And it's one of those just fundamental things in statistics that error is always going to happen. You know, that's just the way life is. Error happens, and so we account for that by giving a confidence level. Yeah, so at this level, definitely you would just go straight to 0.05 because that would be the level of significance that you would run a test at. Okay. All right, and then so to what you would do, especially at a later level, and this is unpacked in those notes that you guys have pretty well, is how you would make the decision. And so if you remember the thing with the 1 and 2 tail tests is that the tails, so the end bits of that bell curve, are what that critical region is. So essentially what's happening here in this table is you're choosing a figure, obviously based on criteria, that is the cutoff for that critical region. And so the rule to make any decision for any statistical test, unless otherwise specified, is that if your value, the value you calculate, so when you go and do your formula and the answer you get, if that falls within the critical region, then you reject the null hypothesis. And if it falls outside of that region, then you accept the null hypothesis. So you're basically always aiming to try and reject that null hypothesis, because the null hypothesis is always the thing that says there isn't a relationship or there isn't a difference, right? Essentially, you're always trying to prove the opposite true, hopefully, through your experiments, because that's what we're trying to do. We're trying to see, is there a difference? And then that would help you make that decision. Okay. So yeah, that is what this looks like. This is what a t-table looks like. It's a universal table, so they all look exactly the same. Okay, well, not exactly the same, but the numbers are all the same. And that is how you use one. Honestly, the chances of this coming up in your exam are like less than 0.5%. But yeah, obviously going through it so that you understand the process. Okay, so essentially, depending on whether you have 1 or a 2 tail, if on the positive side, if the value would be above your critical value, so in this example I was just verbally talking about was 1.66. If your value was higher than that, then you would reject the null hypothesis because it's on the other side of that criteria. But then if it was negative, so if you get it, and then it's symmetrical, remember, because you have a normal distribution. So what is the critical region on the positive side is the same for the negative side. It's just the negative of that, the very image. And then, yeah, so then if your value was, yeah, it's also negative numbers are hilarious and trying to use this like in words, but yeah, if your number is past negative 1.660 on the other side, then it would be, you'd reject it. Okay. Cool. So let's do an example. Let's say this, and this is quite similar to possibly a scenario you'd be given. You know, it wouldn't be too involved. It would really be a pretty simple scenario, just giving you a little bit of context and giving you the values that you need. Okay, so let's say you surveyed your classmates to see how well they did on the final exam. You want to know if they performed significantly differently from the general population of all PSYC students from across BC campuses. And giving it to you on a silver platter. The population mean, so this is the mean for the rest of PSYC students across all campuses, is reported at 62% in this case. Okay. All right, so I have just, for context, given you some hypotheses here based on this scenario. You would possibly be asked to create hypotheses from a scenario. Okay, so who can tell me if this is a one or a two-tailed hypothesis, set of hypotheses on the screen at the bottom here? Okay, good. It is two-tailed, and that is because it is non-directional, simply saying that there is a significant difference. Okay, if the scenario, and it's here, you just want to know if they performed differently. Okay, that's the clue. If this had been worded differently, so if it had said you want to know if your class performs significantly better than the overall population, that's directional. You're specifying that you want to know if your class did better than the other campuses. Okay, so that would be a one-tail hypothesis. Conversely, it could be worded negatively. You could want to know if they performed worse than the general population of PSYC students, and that is also a one-tailed hypothesis. Okay, so always just ask yourself, is there a direction here? Is it specific, or am I just asking if there is a difference? Alrighty. So yeah, just also again, this is how hypotheses would look. Yeah, so just a null hypothesis is always that kind of negative one. There is no significant difference. Okay, and then in this instance, these are the variables. So between the general population and my PSYC class, for instance, in this example, and then alternate hypothesis, there is a significant difference. Okay. So yeah, if you're asked to create hypotheses, they should be looking something like this. First of all, just making sure that the notation is correct, that you do the null hypothesis first, H0, and the alternate hypothesis next, H1, and then that you use the correct kind of buzzword, right? So if you're doing a t-test, you're looking to see if there's a significant difference. But if you're doing a correlation, you'd be looking to see if there is a relationship between the variables. Okay, are we together? Okay, so a reminder of how to, remember step one is to calculate the mean, which I'll show you now, and then step two is to calculate the standard deviation. So it's just a reminder on how to do that, and this is what your little table would look like. It would just be minus this column, because it's not really necessary in this situation. But yeah, table, and you'd work out your standard deviation using the formula. Okay. So what I have done for the sake of time is I did this on Excel, just so that we can show you guys how this is done. Okay, so again, I don't think you'd be required to necessarily make your own table. Just given the brief from last year and given the past papers, it takes too much time. They're far more likely to just provide you with the table, possibly with some missing numbers, and you'd have to calculate those specific little ones. And then just from the data you're given, you'd then be asked, for instance, to work out the standard deviation, possibly. Okay, but yes, we are going to do it. Yeah, so that's why I just did it in this instance. But just, again, just know how to do it, because nothing is promised. And if you are asked to do it, you don't want to be panicking about it, right? Right, but this is essentially is what that would look like. So we have our values under X. These would be the grades in the scenario on the previous slide. I worked out the mean was 70.25. Okay, then I needed to work out what X squared was. So it was taking the first column and squaring that number. Okay, And then I did x minus the mean, so the first column minus the second column, really, okay, for all of them. And obviously the mean stays the same for the same group. And then that's where these values came from. And then the last step is to take those values in this column and square them. And then that's where these numbers come from. Okay. And also just remembering, so should you, even if you're asked to just do like one value in a table, when you square a negative number, the negative goes away. Okay. Negative times a negative equals positive in maths. And what you're doing when you're squaring something is you're timesing it by itself. Okay. So that's why, even though they're negative numbers here, they are not negative in this final column. Okay, and obviously because I did this on Excel, there are lots of decimal places, but you must just stick to 2 decimal places. Okay, yeah, Ashton, so about 20 marks of the exam will be to do with statistics. So it's really not that much, considering the entire paper would be out of 120. Okay. But yeah, we're going to get to that. No. Okay, anyway, and then we get the sum. This is really the figure you're after at the end of the day, because that is what we pop into the formula at the top here. Okay, so to work out the standard deviation, let's just go over to, oops, didn't mean for that slide to be there. Okay, I'm going to just exit this mode. All right. So let me just, the value, or, yes, okay, so 2118.25. Just going to write that down quickly so that we can go through this together. Okay, cool. So essentially from this whole endeavor with the table, this is the value that you've been after the whole time in order to work out the standard deviation, because this is this top bit of this formula here. It is the sum of the values of x minus the mean squared. Okay, I wrote it in words here because Excel was being annoying, but yeah, also just to show you what that means. So we're going to take this value and we're going to sub it into that formula. Okay, so I'm just going to draw under here. We've got 2118.25 over n minus 1. Okay. I forgot what n was. How many? What is n here? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, always good to just go and check that. So we know what n is. I could have just put 12 in there, but we'll just do that together because I think we're capable of minusing 1. Okay, so 2118.25 over 11, because that's what 12 minus 1 is. Okay, cool. All right, so we can just, let's do the inside step before we take away the square root. Would anyone like to just quickly just calculate what that is for me? What is 2118.25 divided by 11? Yeah, 192 points, and it's 57 because we're rounding to 2 decimal places. Okay. Right, and then we just need to square root that, anyone, to get the standard deviation? Oops. 13.88? Yes. Okay, excellent. So now we have that value. And that means we actually have everything we need to solve for t. So should we go and do that together so you can see what this formula looks like being hashed out? I actually just want to move this so that I don't have to rewrite it. Sorry. There we go. Okay, so the mean we had here was 70.25. So we'll just go ahead and pop that there. Never forget the decimals, especially if they're given to you, because it will affect your answer at the end. Okay, now we need to know that population mean that we're comparing it to, and I think it was 62. Let me just check. Yes, okay, that was given. Okay, no, Pop. Sorry. my dog doesn't like maths either. Okay, 62. Alrighty, over, and now S we've just worked out was 13.88 over the square root of n, which was 12. Okay, so I don't know about you guys, but I always used to break out in hives when there was more than one fraction going on in maths. But yeah, so let's just go step by step here. Alrighty, so what is 70.25 minus 62? Well, Seema, it doesn't matter because you're not going to do it in one step, remember? We always break it down so that you get method marks, because when you're asked to do this, you will always get method marks, okay? You never want to just do this, because then if you accidentally put the decimal in the wrong place and you get it wrong, then you don't get any marks, and that's sad. Okay, 8.25, lovely, 8.25 over. Okay, and then we can simplify this a bit. So, I mean, you could do this in lots of steps, but it depends. What is the square root of 12, I guess, just to break it down slowly? Anyone? 3.46, correct. Okay, now we can get rid of this horrid fraction at the bottom. So what is 13.88 divided by 3.46? I'm not doing anything to the top part in this step. 4.01, lovely. Okay, and then now we can do the final little calculation to get our t-value. 8.25 divided by 4.01. Should be 2 point something. 2.06. Excellent. You'll find a lot of the time that t-values with the like sample size that you guys have to calculate are within this like 2 range. 2 point something. Okay. Lovely. So we've worked that out, and then the purpose of that would be to go and compare it to our critical value so that we get answers. Okay, so that we complete the cycle, let's consult the table. I know it's really small, so I'll just tell you guys what the value is. So n-1, remember, was 11. So that would be here. We did a two-tailed test, so we're looking at this row at 0.65. So this column and this row. And then we're going to go to where they meet. Hopefully I don't go skew. No, 2.201. Let me come and write that here. Okay, so our critical value is was it 201? I'm like a hamster with my memory these days. Yes, haha. Okay. All right, so as we can see that these values are close, but they are different. And because they're essentially what we would be doing, change colors again, always visualize this thing. Okay. And essentially the critical value goes here. So this would be 2.201, just to tie back what I was saying earlier. Okay, that's minus 2.201 because it's two tails. There is the possibility of the minus. It exists, but we don't care because we've got a positive number. Okay, so is our number 2.06 bigger or smaller than this number, 2.206. Put the midline in. Correct, it is smaller. So that means it would probably fall like here somewhere. I mean, close, but you know, on this side. So that would ultimately lead us to accepting the null hypothesis, that there is no difference, that they performed statistically not significantly different. Yeah. So you accept the hypothesis. Okay, if it falls on this side of that line, you accept or fail to reject, whatever, same thing. And then if it falls on this side of your critical value, you then would reject. And remember, it's always in terms of that null hypothesis. H0. Okay, so what that would mean, and just translating, so going back to the wording of the hypotheses, which was here. So we found out that we'd have to accept the null hypothesis, which means that there was no significant difference between the general population and my PSYC class. Everyone is average, apparently. Okay, obviously these are made up numbers, so it doesn't mean anything. It's just the example. Okay, so rounding up. If you are asked to calculate a t-test, the important things that you need to remember are to obviously work out the mean for your sample. You would be given this population value you're comparing it to, and you would need to then work out the standard deviation. Okay. You could also just be given that value. It's possible. And you know, guys, thinking about it, you have a 2-hour paper. That's a mark a minute. You know, how long has it taken us to do this? It's really unlikely they're going to make you work out all of these things. They'd make you work out maybe one of them. Okay. So obviously don't leave anything out in your studies, but just be prepared to take the information given and then take it from there, basically. Okay. Okay, any questions on the one sample t-test? Alrighty, okay, so very much the same logic applies to the 2 sample. Let me make this a bit bigger. Or the independent t-test. So what happens, why this one comes into play, is when you have 2 groups that you want to compare the mean of, you know, to each other. So most commonly is when you have an experimental group and a control group. Yeah, that's really where this comes in. Okay. So the point really is that if the scores differ, if the mean of the 2 groups differ significantly, you would know whether or not then that your independent variable is actually working. So if you think about a scenario in which you've got an experimental and a control group, and you're testing the effect of some kind of medication, and if you can find a significant difference between the experimental group, so the ones that get the medication, and the control group, the ones who don't, that means that that variable that's changed, which would be the medication, is having some sort of effect. Sorry. Okay, so that's really the purpose of this, is essentially to be able to figure out whether your dependent variable is, your independent variable is doing anything. Yeah, so this would be, in my example, my own 2 groups. So that's, and what I did for this example is just to separate into males and females in a class, because it's the easiest thing to do. But yeah, when you have 2 different groups and then you compare them. Okay, so this is what this equation looks like. I do not believe you would be asked to do a 2 sample t-test simply because of the time that it takes to do so, because what we just did essentially for the 1 sample, you have to do twice for each group. Okay, so if we break this down a little bit, this with the little 1, and I think this is just what makes this formula look confusing. So if we understand what the little 1s and 2s mean, it's less intimidating. So this is the mean for group 1, okay, so for your first sample, and then this is the mean for group 2, or your second sample. Okay, and then, so if we remember, I had to edit this image because it was wrong, S squared is the variance. Okay, so when you're doing an independent samples t-test, you're working with the variance, not with the standard deviation in the formula. Okay, and it kind of makes sense because it's all under a square root anyway. But yeah, so if you just cast your minds back as well to the standard deviation, what standard deviation is the square root of the variance. Okay. So then you'd have to, you see what I mean about time, because you'd have to then work out the variance for each group that you've got, and then you'd sub it all into the formula. Okay, so if you were asked to do something to do with this test, they would be giving you most of the data you need, and then perhaps you just have to carry out the final equation. Okay, and then N1 and N2 can be different, so that's why they are denoted as N1 and N2, okay, because it is possible to compare the means of two sample groups that have different numbers of people in them. If you think about it, they're like this, your class, there are significantly more women than there are men, so the N1 and 2, actually, if we were to work that out, would be different. Okay, obviously that is important to keep them all together, keep the 1s with the 1s and the 2s with the 2s, okay. So yeah, this is just the slide again, it's the exact same steps that you go through, it's just that you do this one twice, so you work out the variance for each group with the same formula, the same method with your little table, okay. But yeah, you're just not going to be asked to do this. You don't have enough time. If it was a 3-hour paper, maybe, but it's not. Yeah, so this is how one does this. Okay, same steps. You're just basically doing it for each group and then putting it together in this formula. And then, so when you find the t-value, the degrees of freedom is worked out slightly differently because you have two groups, and this is how it is worked out. It's N1 plus N2 minus 2. Yeah, so you would, if you did have to work this out from scratch, and it would be good for you guys to do it as practice, if anything, just to, go through the process to help you learn when you're practicing for the exam. You'd have two tables. This would be for group 1, so this is literally the table we had before, and then you'd have another one for group 2, which I will show you in a second. Yeah, I think you can pretty confidently assume you would not need to panic for this one. I don't even, if that statement even makes any sense, I don't know. But yeah, they didn't even ask the honors students this year to work out a 2 sample t-test in the exam. So it's a time thing. So don't leave it out, but it's not likely to be asked of you to do the whole process, okay? So these are my 2 tables. What I did was made up a and the first one that we've been using became the males and the second one became the females. So you see that the means are different. So the females mean was 72, and obviously just different scores. Don't try and check that. I made it up because I made an error. It just doesn't matter, okay? Just for this scenario, believe that the mean was 72. And then that's how the rest of these values were calculated in exactly the same way as for the first table. Okay, so we take the x values, we square them, we do x minus the mean, which would give you these numbers, and then you take this column and you square it to get the final column, and then ultimately what we're after is summing those values up to get that value. Okay, so that did in turn then would allow us to work out the variance for each group, which would allow us to then do the t-test. Okay, so should we run through this? Do you guys want me to run through this very quickly just as a form of practice for the formulae? Working out the variance, I'm happy to do so. Righty. I did forget to copy and paste the table here. So, okay, so that was 2118. Oh, we have the variance of the previous one. It's fine. We'll work it out again. Okay. Okay, so let's put here, this is group 1, which was the main. Okay, so we worked this out from our table, was 2118.5 over, and n stayed the same, it was 12 minus 1, so I'm just going to go ahead and put that in here as 11. Okay, so if anyone recalls, what was this value? 2118.25 divided by 11. Yes, 192.57. Okay, so that is the variance S squared for group 1. Okay, let me change colors for group 2. Now I just need to consult that table for what it was. All right, so we worked the sum, the value was 2478. Ooh. Okay, and n was the same, so over 11. Anyone like to do the honors for me? 2478 divided by 11? N minus 1. Okay, 0.27. There's always arguments about the decimals. It's funny. There we go. 0.27. Correct. Okay, and now we have the variance, so S squared for group 2. Okay, not too bad, all in all. Let's now do the T formula, because we have everything we need. Okay, so we had the mean for group 1 was 70.25, and then the group 2's mean was 72. Okay, don't forget the square root. Okay, now our first variance was 192.57. Okay, over, and remember now it's over n, not n minus 1, okay? So now it's 12. We had 12 participants. Okay, then we go back and find what our second variance was for group 2. I've got to write group 2 here. There we go. 225.27. And n was the same. Okay, so over 12. Okay, let's break this down. So what is 70.25 minus 72? Yes, minus 1.75. Okay, then let's get rid of these horrid fractions first, I believe. So what is 192.57 divided by 12? Lovely, 16.05. And then 225.27 over 12. Is it 0.78? 0.77. What's the third digit? So then, yes, so then it would be 77. Right, okay, so 18.77. Delightful. We're nearly there. Okay. Let's leave the top alone for the moment. Ooh, Where's 575? Okay, what is this? 16.05 plus 18.77? Ashen's on fire. 34.82. Does anyone concur? Sounds about right. Lovely. Okay, then we can do, you can just do this last one in the final step. And I hate running out of space, but let's break it down. So what is the square root of 34.82? Anyone? Okay, 5.90 or just 5.9. Let's just continue over here. And then what is our final answer? So it's minus 1.75 over 5.9. Okay, minus 0.3. We have a t-value. Okay, and again it makes sense that it could have been a negative value because we did a two-tailed hypothesis. Simply, was there a difference between the male scores and the female scores in the class? Okay, let's finish off the process. What is the critical value for this scenario now? Okay, our degrees of freedom for the independent test is N1 plus N2 minus 2. So 12 plus 12 minus 2. 22, right? Okay. So then we'd be looking, dogs. Okay, 22. It was two tails, so this very same column. Okay. 2.074. These scores are unsatisfying because it's a made-up example. 2 points. I feel like, wait, what? Yes. Okay, so if we had to go and put that on our little thingy, here is minus 2.074. This would be the mirror image, so positive. Okay, now, so where does our t-value fall on this line? Is it bigger or smaller than negative 2.094? And this is always the one that makes you think twice because of the negative number, but is it closer to 0 than this one? Yeah, so technically it's a larger number, but I do know what you mean. It is on this side of the critical value, so it would be over here somewhere. Okay, so following that logic, yes, we would accept the null hypothesis again, that there is no significant difference. Which honestly you can kind of see, right? The values are very much similar, but statistically we've now come to that conclusion. Okay, questions? I know it is a lot, but really it just comes down to practice. Practice always makes progress. You write my exam for me? Oh, no, thank you. I swore off exams a while ago. Never again, if I can help it. Okay, I think let's take a quick 5-minute breather and then we will come back for essentially what will be our NSS part of the session. And we'll go over the exam, the requirements, expectations, fears, all of those things. Okay. And obviously, yeah, if you think of any questions in the 5 minutes, then we will begin with those. Okay, I'll see everyone back here at 6 minutes past 6. Okay, are we back, everyone? Okay, cool. Let's have a look at what the brief looked like last year. Okay, let me just make that a bit bigger. There we go. Okay, so obviously disclaimer on this. It was last year's brief, and the instruction we were given was that obviously it's not, the brief wasn't designed for this year, so it could essentially be a bit different, but obviously broad strokes apply. So I believe it is worth sharing with you guys to show you what the paper looked like last year, and obviously we'll have a look at that past paper as well. Okay, but these kind of rules will apply for the same thing. Okay, so this is, and obviously the brief was constructed because everyone was freaking out about the statistics, that portion of it, okay? So there will be about 20 marks for calculation out of the whole paper around statistics. So that is 20 out of 120. So therefore, yes, it is obviously possible to pass the paper if you fail that section, because it's only a percentage of it. But give it a shot. Never just leave out 20 marks. Please don't do that. It's dreadful when that happens. Rather just try and get marks where you can. Okay. But obviously the rest of the paper is based on the rest of the module. So it is important to kind of center your attention on the other learning units as well. Okay, so all learning units are examinable. They are unlikely to leave any out. So just bear that in mind as well. Okay, and so what they did say last year was that you wouldn't need to calculate a whole equation from the beginning. Okay, so that's like I was saying now. You wouldn't need to do every step in the process, for example, of working out a t-test. They may just get you to work out the standard deviation, or they would give that to you already so you could do the rest of it. And really, it's about that time constraint. So what is important is to remember to kind of read the question a couple of times and make sure you understand the information that is given to you. Okay, so I have uploaded a couple of past papers that I found as well on your Learn module. You will see it in more resources in its own little folder. Yeah, I'm not sure which ones you guys have access to, but yeah, I've put a few there. And if I do find any more, I will share them with you. But do bear in mind that this module was kind of reassessed and restructured a couple of years ago. So yeah, the older the papers are, the vast more different they are. So I think anything before 2019 and even some of the 2019 paper is irrelevant to you guys because of the way that your module has been restructured. Okay. So all exams are based on the learning objectives in a module outline. So if you are going through a past paper and you see a question that just doesn't make sense because it's not something you covered, go and check in your learning objectives in your module outline. And then, yeah, if it doesn't appear there, it means that it won't pop up in your paper because it has been taken out of your module. Okay. Right, so this is kind of the most important thing from this brief is that you need, as long as you understand the equation and what it requires you to do, you will mostly just be inputting or substituting figures that you are given. So learn what the symbols mean in the equations so that you know that you would be able to substitute the values that you are given into it. Okay. And yeah, obviously, I mean, you can get away with having a normal calculator, but a scientific calculator would be better. Don't forget to take it with you. Okay, so what they did was provide a couple of little sample questions, and then what I did was put pages of the textbook that would help you find the answers to them. This was from my class from last year. And this doesn't mean that this is exactly what your question would look like. It's just the broad idea of what a question would look like. Okay, the questions in an exam paper tend to be a little bit more involved, especially if there are for a whole 8 marks or something. But again, and as we go through the past paper, you will see the kind of patterns that are happening in this exam, and it's pretty simple to see. Sorry, yeah, the kinds of things that you need to learn about. Okay, sorry, actually, I need to take this call because might be an emergency. Just give me 1 minute. Sorry about that. All good. Okay. Where were we? Sample questions. Okay, so it's worth taking a look at these sample questions, if anything, to see how they ask these kinds of questions. So this kind of question has come up quite often, this differentiate between kind of social and natural sciences. It's quite a nice, easy theory question, comes straight out of that like first learning unit, you know, early on in your textbook. It's a nice question that could pop up early in the paper. Yeah, very likely to come up with something to do with sampling. So it's possible that they may ask you to identify a sampling technique that was used in a scenario that you're given. That's happened before. Or they could simply ask you to something very broad like this, like just discuss sampling. And yeah, like what type of sampling would you use in a given situation? So a lot of these exam questions will be scenario based. And you'll see that even from past papers. Yeah, just another kind of example, you know how to do this kind of thing. Like if something has, for instance, characteristics, know how to identify them. Another pretty common question is, what are the characteristics of scientific research? Remember that was in your first assignment. So that kind of thing. Just know those kinds of things and how to discuss them, possibly given an example. This one, yeah, it's just straight from the textbook kind of thing. You know, what are the 5 characteristics of causal hypotheses? Yeah, and just another note on that is that when these exam papers are made, they basically, the developers get your module outline and they get your textbook and they say, go make questions and the memo. So your textbook really is king when it comes to answers and the correct answers for learning for this exam. It's what the memo will be based on. So it's what we'd be looking for from any given question. Okay, there's just a couple of little more examples. Yeah, like for instance, this one, so since Johan will be working with sensitive topics, discuss the importance of trustworthiness in qualitative research. Okay, any 4 tools he could use to increase trustworthiness. So yeah, again, this is straight just from textbook knowledge. What is trustworthiness in qualitative research? And yeah, there are 4 aspects to trustworthiness. What are they? And because they've given you kind of a scenario, you could give examples in that case. Conversely, they could ask you about validity and reliability. That's possible. So do go and study the definitions of those things. It's just likely to come up. They could ask you simply to define validity and reliability. They could ask you to discuss the validity of a certain situation, perhaps, that kind of thing. Yeah. So know the different types of validity and how to secure that validity in a quantitative situation, a quantitative experiment or a quantitative project. Okay, very likely I'm almost completely certain that you will be asked to construct a null and an alternative hypothesis, and it could be for up to 8 marks, which I think is insane, but you know, Merry Christmas. Yeah, so that is very likely to come up. It's something that is definitely worth practicing. And then this kind of thing, so this last one is something that they've done much more often than actually make you do a whole calculation, and it's actually to interpret a result, particularly with a correlation. Because remember, you can tell a lot from a correlation just by the number that you're given. So for instance, in this example, you're given a value of negative 0.43. So what are the things we can tell from this? Like, what do we know immediately from this number if we have an R value of negative 0.43? What is the strength of this relationship? Weak, correct, absolutely. And yes, negative. And then you would likely, because it's 8 marks, need to explain what that means. So with a negative correlation, as X increases, Y decreases. Okay, and then given the variables you're given, you'd use the words to explain that. So it's that basic kind of theory that's testing your knowledge of what correlations are and what they are used for. And it comes down to this interpretation. They could give you a scatter plot and ask you the same question, and you could actually deduce the same answer without even having a value. Remember, just depending on what the scatter plot looks like, that's possible. But they obviously do like to give you a value because it's more secure. Yeah. And again, I have found that they do like to ask about correlation more than they like to ask about t-tests in these exams. So definitely worth this being an emphasized part of your studying. Okay. Yeah, look, the brief, because this brief was given because this was the first paper that was written in person again, I think, on this system in this year that started with 2023. So that's why it's a short brief, because the only thing anyone was apparently interested in was the stats and that kind of thing. Okay, so I think, oh yeah, and any questions so far? But what I'm going to do is head on over to that past paper. Just need to locate it, so another tab. You know you have too many tabs open when you can't find a PDF. I think it's this one. Yes, okay. Okay, so this is what last year's paper looked like, and this is exactly what the front page of your exam will look like. Yeah, you'll have 120 marks, 2 hours, plus this 10-minute reading time. So what's really important about this 10 minutes is that this is your time to center yourself and to breathe and to come to terms with what is in your paper. Okay. So use this time, read all of the questions, decide which ones you want to start with. And what you'll see with this paper is that it was a bit rude in that there was maths in the first question. And I think that threw people slightly because, you know, you're not expecting it. You're kind of expecting the stats to be at the end because it was the last learning unit. But yeah, that's what this 10 minutes is for. Just if there's a question that throws you, you know to leave it until later. You can decide what to start with, that kind of thing. You can make little notes in the margins, anything that helps calm you and center your thoughts on how to answer the questions. Okay, and then yeah, just all of the usual instructions. Okay, so this was the first question, which genuinely I found weird. I mean, why would they not leave it till last? I don't know, whatever, doesn't matter. Okay. Many people in the class did leave the question till last. It's just do remember that if you are someone that likes to do that, to please label your questions very clearly for the marker, i.e. me, so that I can see which question you're starting with, but also to not then not have enough time at the end. Okay, so pace yourself throughout this paper. 120 marks, you have 120 minutes, so that's a mark a minute. Yeah, if you find yourself getting stuck on something, move on and come back to it, because you don't want to be leaving out questions because of time. Okay. Yeah, if it will make you guys feel better, we can have a glance at this question now together. So, okay, let's just look at this scenario. All right, so Tom, a postgraduate student, has conducted a study to understand the relationship. Okay, so there's the clue. I mean, the formula gives it away, but that's the buzzword, is relationship, between the number of hours spent studying and the exam performance of a group of 10 psychology honors students. Okay, first of all, before we go any further, let's identify some things. Okay, relationship, obviously we're looking at a correlation. What is the independent and what is the dependent variable in this situation here? That is also something they could ask you. Yes, so the score or the exam performance is the dependent variable. It's the thing that you are measuring. Then the hours spent studying is the independent variable. That's the thing that changes. Okay, correct, excellent. Okay, and then we have N is 10. So you've got a group of 10 psychology students. Okay, so this question, see, this is what I meant when they give you a table and they just ask you to work a couple of things out. So this is why I say it's important to know how the table works, so that you don't just, make a silly mistake when it comes to these 2-mark questions. So yeah, we need to work out what A, B, and C are in the table, and then calculate R. And C, they give you the formula. Okay, let's do A, B, and C then. What is A? So the first thing you should look at is what column A is in. It is y squared. So that means we need to go to the y and square this number. Okay, so 35 squared. Yeah, that's A. Okay, B, x squared. So doing the same thing but for x. 16 squared would be that answer. 256. I'm getting flashbacks to marking this paper. Okay, and then C for 2 marks is this xy value. So we need to times 6 being the x by 20 being the y. So what is 6 times 20? 120. Absolutely. Boom, easy 6 marks. Okay, we're feeling better. They even were so kind as to do all of the sum ups and things for you. I also hope you get a question like this because it's nice to mark, but that's selfish of me. Okay, let's work out the formula then. Let me make it a little smaller so we can actually just kind of do it below here. Okay, first of all, we need to sub in some values. So we know that n equals 10. And then let's go and sub in our things, shall we? Okay, so if n equals 10, then the sum of xy. Okay, so we find xy in a table, and we've got the sum. We're just going to fill that in. T138, sorry, that's skew. Okay, and then we need the sum of x. See, that's this one. 127. And then the sum of y, also calculated for you. Lovely, 168. Okay, now we can do the bottom. Don't forget the square root. Okay, I hate this formula. There's so many brackets. Okay, so we've got 10. Okay, so remember now the difference between the sum of x squared and the sum of x squared independently. Okay, this is the one that you need to work out, and this is the one that you get from the table. So first of all, let's do this one. We've got 1, 9, and this was quite a common mistake, just flashing back to marking this. People like panicked and forgot that, basically, at the step. So just do remind yourselves to work this out separately. And so remember the brackets. You do what's inside the brackets first. So we need to take the sum of x, which was 127, and square that. Someone do that for me, please. Interesting. Okay, 16,129. Again, that's like a number that does ring as true in my brain from marking this. There we go. I'm so sorry that is so skewed. There we go. Hopefully you're following along. Okay, and then that will be times by the same situation for the y values. Okay, so we need the sum of the y squared values. That's this one. 3327. Okay, then can someone please figure out that value for me? It will be 168 squared. 28224, yes. That's a 2. Okay, cool. And then we can work it out from there. Because n is 10, it at least makes these calculations a little bit easier. Okay, so this is 10 times this, so 21380. And then can someone please do 127 minus 168 for me? It'll be a negative number. Oh, no, we're timesing it. Correct. Okay, 127 times 168. I'm so sorry, guys. It's been a very long day. What did you get? 21336. Lovely. It's an excellent sign that you're all entirely ahead of me and ignoring what was coming out of my mouth. Okay. Okay, and then under here we've got 1943 times 10. So add that 0. Okay, do the same for this one. Here we go. Okay, are we all together so far? Has anyone fallen off the bus? I think we're all together. Cool. Okay, let's do the top one then. So 21380 minus 21336. Okay, excellent sign that the numbers are decreasing. Okay, and then we need 19430 minus 16129. 1, delightful. Okay. And then I'm going to put the brackets in to remind ourselves. Okay, so then we need 33. I think that's a 270 minus 28224. 5046. Correct. Okay, then we're going to need that really big number at the bottom there. So 3301 times 5046. Oh, I hate getting such long numbers. Okay. 1, 6, 6, 5, 6, 8, 4, 6. Many sixes. Ooh, okay, then I need this. I'm just going to go over here. I need the square root of that long number, please. Okay, 4081. Is it 28 or 27? Okay, don't forget the rounding. Okay, 2 8s. And then final answer, 44 divided by 481.28 gives us 0.01. Yeah, I remember it being like literally the most insane. Okay, and there we have it. That was lots of marks. 14 marks. Yeah, not too bad because they give you many of the values, all right? Yeah, it's very likely that you will get a question very similar to this. And just for the sake of education, shall we explain what does this mean? We have an R value of 0.01. What type of correlation is this? Positive, but very weak. Barely there. Okay, because it's 0.1. If it was 0.1, it's still weak, but stronger than, like, this is literally as weak as it gets, kind of. Okay. But yes, positive. So if you had a scatter plot, the dots would be, I mean, they'd be far apart with this kind of thing, but they'd be going in that direction. Yeah, remember, with a correlation, it's about how close it gets to -1 or +1 is how strong it is. If they don't ask, you don't need to say that, no. And they just asked you to calculate it in this question. And that's because you'll see in a later question, they ask you to interpret a value that they give you. Okay. So yeah, the rest of the paper is actually quite nice. And then it's just the end, there was a little bit, but this is mostly theory. But let's just have a glance here at question 2. Okay, so this is what I was saying, Nana, with the properties of scientific research. That's straight from your first assignment. Yeah, asking you to apply the properties of scientific research for this little scenario quote that you've been given. Okay, so 12 marks. You know that there are 5 scientific properties. So, I mean, it's almost a weird mark allocation. If I remember correctly, there were 2 marks per correctly applied property. And then kind of there were a bonus 2 marks for coherence or something. Yeah, so the closer to, for correlation, the closer to 1, the stronger it is, and then the closer to, or closer to -1. And then, yeah, the closer it tends to 0, the weaker it is. Okay, so you can even see this literally is the same question that was even on that brief. They asked to differentiate between social and natural sciences and then give an example. So quite a straightforward question if you have studied for the paper. And I think just from marking, and I think a lot of the other campuses said the same thing, was that those who were prepared for this exam did very well in this exam, and then those that weren't did very badly in the exam. It was almost kind of one of those situations. So yeah, it's one of those things, just make sure that you are prepared. Go through what have been the main points of your learning units and make sure you're able to apply that theory. Okay, question 3 was all about ethics. You are very likely to get an ethical case study question like this. They love asking this, and it's a nice question because yeah, if you remember the ethical principles and if you understand them, you should be able to fairly easily motivate for these marks. So for this one, they gave you the little Albert example. They could give you any, I mean, they could do any kind of famous psychological experiment. They could also just make up a scenario. I really don't know what they would give, but it could be anything like this, in which there are clear signs of ethical violations. You would just have to read through it and then identify them and then speak about them. Okay, so I mean, the first question that leads into this one is a nice little 5 marker, like why are ethics important in research? And then, yeah, the 3.2 or for 20 marks was that you had to discuss, and it asked for 4 ethical guidelines that you would take into consideration when conducting research. So yeah, we know that there are 6 main principles. So basically you needed to, in this instance, speak about any 4 of those and related to this case. And there were 5 marks basically per principle identified and then explained, if I remember correctly from this memo. Yeah, again, very likely to get a question very similar to this. Scenario, apply the theory that you've learned, especially around ethics. I think that you can also see, and also for the 2022 paper, you can actually see how your 2 assignments do contribute towards this paper, but even more so that first assignment, because it really broke down a lot of those principles of research. Okay, question 4. I hope you don't get one exactly like this because the options are hard to mark, but I mean, it makes it more interesting for you guys. So you had to choose one of these topics. I think it was just whatever spoke to you. It doesn't matter which one you chose. Obviously there's no like wrong answer here. And then they made you do things like you had to do an assignment 2. So construct a research question. And then yeah, for the 5 marks, we were looking for things like the correct wording. So if you were, and then also they gave this important clue, actually, this is important to highlight here. So there is a relationship between the 2 concepts. So this is what they're telling you that they're looking for here. Yeah. So yeah, construct a research question. There isn't necessarily even a wrong answer to a question like this. It's just that they are, make sure that you don't contradict yourself in the question. So make sure you mention both of the variables and that your question makes sense in terms of a relationship. Okay, and then discuss which type of research. And honestly, like this gave this away for me. Sometimes they do this. They leave you giant Easter eggs in your question paper. There's a little Easter egg. So they've told you here there's a relationship between these concepts. So that already gives you your answer to this question. You're looking for quantitative, but more specifically, remember, type of research, correlational. Yeah, so when they ask you for approach, it is quantitative, qualitative, or mixed methods. They ask you for type, it is correlational, explanatory, exploratory, or descriptive. Okay. Straight out of your textbook there. And yeah, from both assignments, I think, if I remember, you have to do things like that. Okay, this question asking you to distinguish between operational and conceptual definitions, and then use the topic to help you explain. It was 10 marks. If I remember correctly, you got 5 marks for explaining what operational definitions are, and then 5 marks for explaining conceptual definitions with using examples. That is how those questions work. And then here, so discuss sampling theory and how you would implement it in this research topic. Okay, so things that were important. I hate odd numbered mark allocations, as an aside. But anyway, so you were asked, they had to here choose a correct, and there was a wrong answer here, right? Because if you've set up in this example a quantitative method, which you should have, then your sampling needs to make sense, and it needs to be a probability-based sampling technique. So simple random sampling, probably, yeah, that was the easiest one to use. Stratified, if you wanted to make it complicated for some reason. But basically, you got marks for this if you identified the correct type of sampling. So you needed probability-based sampling, and then, for instance, simple random sampling, and then just explained how that would work. Sure, Luca, we can do that in a second. Yeah, let's just look at this last question. Oh, and also always remember to find where it says end of paper, because I mean, I've heard horror stories where people like forget to turn the page and leave questions out. That's just a general exam skill. Yeah, so look, the correct answer here was quantitative. I think that there were ways to get marks for qualitative, and it was the same thing for assignment 2. It was just difficult to motivate for that. Okay, so yeah, look for the Easter eggs in the questions. Okay, and then this last question, so they gave you here, Cunningham, wow, is a lecturer and researcher at IEVC NMB, and he is investigating the relationship, so again, relationship between the number of hours students study and their exam marks. Okay, so you're given a table, and they ask you to do various things here, which are mostly theory-based. Okay, the only other calculations you had to do in this question was just these descriptive things, so the mean, median, and mode. Okay. All right, so you will notice you're not given a formula for these things. You're not given the formula for descriptive statistics for central tendency. You must know how to work out the mean, median, and mode for a data set. Okay, so properties of a normal distribution. So this is a favorite question as well. They even asked this question exactly like this in the honors paper. For 5 marks, you could draw a picture, but you don't get special marks for that. But it's a bell curve shape, symmetrical, normal distribution. That's those kind of properties of a normal distribution. Okay, so these kinds of things, right? Just remember these kinds of definitions. Okay, then now they've asked you to interpret an R value for 6 marks. Okay, so remember, there's basically 3 things that you always have to do when you're given an R value. You give the strength. So is it weak or positive or strong? You give the direction. I don't know why I tried to write this in words, anyway. And then you explain what that means. Okay, so that would be the 6 marks, literally. So this 0.93, okay, that is very close to 1. So yes, it is a positive, it's a positive number, strong correlation. So what does that mean? If we're looking at these variables, if I say there's a strong positive correlation between hours studied and exam marks, what does that mean? You're very likely to get a question like this, so that's why I'm putting emphasis on it. Does anyone want to hazard a guess? Or educated guess? Yes, the longer that the students spent studying, the higher their exam marks were. Awesome. Hey, you guys are fine. Everything's going to be fine. Okay, and then asking here again, like I said, between validity and reliability. So know the definitions for each of these things and distinguish between the 2. So, yep, you got 2 marks for this definition, 2 marks for that definition, and 2 marks for the difference. And then I love this mind bender one here. I actually thought this was mean for random 2 marks, because obviously whoever made the paper didn't add up at the end. A random true or false question, it could come in. for 2 marks. And this really, if you understand the concepts that they're actually asking about, you can answer a question like this. But this one's almost a trick question. You've got to really think about it. If an instrument has low reliability, is it possible to have high validity? So we need to remember what the definitions are. So what is reliability? I always picture a target, also a square target, when talking about validity and reliability. Okay, so reliability is about consistency. So are you able to get the same results more than once reliably, right? If someone's reliable, they're consistent, they reliably show up for something. Validity is, are you testing what you're trying to test? So do you hit the bullseye? Okay, so if you think about it, if a measure has low reliability, so it doesn't consistently produce the same results, it's not really possible for it to have a high validity, because how do you know you're testing what you're trying to test if you're not getting the same results? Yeah. But yeah, you get a question like this, just, it's 2 marks, okay? If it confuses you, don't let it freak you out. Move on. It's 2 marks, and then come back to it. But at the end of the day, just reason it out. No matter what they ask you, but with a true and false question, it's almost always got to do with your understanding of the concepts, and then it makes sense. Yeah, so for this, you literally just have to, you got 2 marks just for saying false. You didn't even have to give a reason. You don't have to give a reason if it doesn't say so. And that was this paper. So truly not that bad. And I know it's easy for me to say that, but I have seen worse. It's a good paper. It's a fair paper. At the end of the day, it's testing these fundamental points of knowledge, okay, in the learning units. You wanted to go back to the scientific properties one. I can't remember which question that was. Was it this one? No. Which question was that in? Oh, right. Okay, question 2. Okay, so properties of scientific research, there are 5 of them. Does anyone remember? There's a pretty slide. It's got hexagons on it. Yes, yes. Empiricism, falsifiability, logical and systematic. Correct. 2 more. Yep, reductive. What's the last one? Replicable. There you go. Nailed it. If only you guys could write it as a group. Imagine. Okay. Awesome. Cameron, could something like this happen again? I mean, it could happen again. I do think your paper will be quite similar. At the end of the day, the same sort of fundamental principles will be tested. And even if you go now and compare this paper to the 2022 one that I did upload there for you guys, you'll see how very similar they are. This one is the 2023 one, yeah. I had the 22 one somewhere. Yeah, I did upload it, I'm pretty sure. But and I mean, we've pretty much run out of time, but it is very much the same. But do remember that 2022 was a slightly different module, so there are some things in here that are not in your module outline. Okay. Yeah, look, the 2019 paper, there are definitely things in there that do not apply to you guys. So just approach with caution. Okay, use these things for practice, but yeah, don't be freaked out if there's something you don't know. Here's an example, right? Like, look, they've asked the same things again. So ethical principles. This is always a fun question. They give you a case and they ask you to discuss the principles that were violated. And that's lovely because you've got things to draw on there. Yeah, see, this paper didn't ask about sampling, it asked about data collection methods. So can you see how that happens between years? So, and I mean, they could ask you about sampling again this year. They could also ask you about something else to do with methodology. So just make sure that all of those steps in the research process, you understand, okay? And also note, I think one of the past papers even asked to name the steps in the research process. So that's like a free 10 marks, usually, if you can remember them in order. Right, cool. So yeah, you guys can go over this, see a very similar situation even for the maths one here. Okay, release of marks. I know I do apologize. I'm at certain that they will be out. Well, I mean, I'm not actually ever certain of anything, but hopefully by the end of the day tomorrow, you'll get the actual marks. But hopefully you guys saw the feedback document. I sent an announcement last night. Did you guys see that? Can you access that document? Yes, okay, excellent, good, because that's really what you need. You need that. And yes, as a whole, the class has done well. They really aren't, I think so far they've been like less than a handful of fails, and it was just because whole questions were left out, that kind of thing. But yeah, no, I know, I understand. But look, you basically, in that document, you have the correct answers and examples of correct answers. So I just wanted to make that available for you guys so that it will help you with studying for these kinds of things, just to see your logic if you are asked to, create questions and hypotheses and things. Yeah, I know it's been such a delay. And yeah, I do, like I say, I'm sorry. It's just there've been so many variables out of everyone's control that's been happening. But yeah, they definitely, I'll do everything in my power so that you have your marks. Hopefully, yeah, end of business tomorrow. Okay, so I sent an announcement, but what I'll do is that I will upload that document as well under more resources so that you guys have it. Is there a 2021 paper? There was a 2021 paper, but it was a take-home, so it's not really applicable. I'll have to go and check quickly. Yeah. It's always a vast difference but when this was a take-home because, obviously, like, you guys have experienced take-homes. I think you should have probably in your first year, maybe you had take-homes. Yeah, just the way of questioning is so different. So they're not necessarily that helpful in terms of exam prep.